Hello, College Algebra. Welcome to our lesson on 10.3, Determinants and Cramer's Rule. I apologize that my voice is not back yet. I've waited a whole week to get my voice back and it's still not back, and I can't delay making this video any longer. So I ask that you be patient with me, and let's go from here. So this is about determinants and Cramer's Rule. We did learn about determinants in Algebra 2. As a refresher, if you're trying to find the determinant of a matrix, you're first going to look at the downwards diagonal and multiply those numbers together. Or in other words, you would multiply A and D together. Then you would take the upwards diagonal and multiply those numbers, and you would multiply B and C. And once you multiply those two numbers and you have those two results, you are to subtract them. And that would get you your determinant, or DET. Just remember, the downwards diagonal must always go first. The upwards diagonal must always go second. So with that, let's do a couple examples on the next slide. So we're going to find the determinant of these following matrices. Start with the top one. You'll do the downwards diagonal first. So -2 times 3 to get -6. Then the upwards diagonal, -1 times 3 to get -3. Once you have those two numbers, subtract them. The minus negative becomes plus positive. So -6 plus 3 will give you -3 as your determinant. And that's all you have to do. Let's do one more example. This one, downwards diagonal first. Multiply those two to get 12. Then do the upwards diagonal. -4 times -3 to get 12. And once you have those two numbers, subtract them. And of course, 12 minus 12 will give you 0 as your determinant. And that's it. Easy peasy. The next one, we'll still do the determinant. It just looks a little weird. Let's do the downwards diagonal first. Now, the way this is going to work is you're going to multiply the numbers first to get 4. Then you'll need to multiply the letters together, which if you multiply those letters together, that will just get you A, B, C, D. And that's how you do the downwards diagonal. Then do the upwards diagonal. Do the numbers first, and you'll get 6. Then multiply the letters together. And when you multiply the letters together, you'll get A, B, C, D. So you have your first determinant, or your first number and your second number. Subtract the two. 4 minus 6 will give you -2. And the A, B, C, D will actually stay. And that will be your determinant. If you're curious as to why the A, B, C, D stayed and did not subtract, it's because it's acting like a variable. For example, if you had 4x and then you had 6x, and if you were told to subtract, you wouldn't just say -2, you would say -2x. So that was very similar to what happened here. And that's how you approach that problem. Not too difficult. Once you understand it, piece of cake. Now to find the determinant of 3x3s. Now, there's actually 6 diagonals that we need to compute here. To find these 6 diagonals, this is what you're going to have to do. I'm going to erase that. I'm going to put that over to the side. What you're going to have to do is take the first 2 columns of your matrix and copy them off to the side. So -1, -2, 4, 3, 0, 1. And once you have that, then you would find your 6 diagonals. Here's your first downward diagonal, and then your second, and then your third. Those would be your 3 downwards diagonals. And then your upwards diagonals would be here, here, and here. And those would be your 3 upwards diagonals. And those are the diagonals you would have to multiply to find the determinant. Now let's show our work on the next slide. Same matrix, we're just going to show our work here. Take your 2 first columns, copy them off to the side. Now, let's do our downwards diagonals first. Multiply all of those numbers together. -1 times 0 times 5, which will just get you 0. And the second diagonal, 3 times 0 times 4, which is also 0. Then the last downwards diagonal, 2, -2, 1, which should get you -4. So those are all the downwards diagonals. Now let's do the upwards. The first one, 4 times 0 times 2, will give you 0. The second upwards diagonal, 1 times 0 times -1, will also get you 0. And then the last one, 5 times -2 times 3. 5 times -2 times 3 should give you -30. So they were off to a good start. Now, next, I want you to combine all of the numbers in blue to give you -4. Then combine all the numbers in red to give you -30. So here's your downward diagonal number. Here's your upwards diagonal number. And once you have those 2 numbers, subtract. The minus negative makes that plus positive. So that's just going to be -4 plus +30 to give you 26 as your determinant. And that is how you find the determinant of a 3x3 matrix. Now moving on to the next example. Now this is something that's new to you. It's called a minor. The minor of the element AJ is the determinant of the matrix formed after deleting row I in column J. So in other words, we want to find the minor of element A21. The 2 represents the row. 1 represents the column. So first, let me go to my rows. I'm specifically looking at row number 2. I'm going to take row number 2 and I'm going to cross it out. Now, I'm going to look at the columns. Column 1, column 2, column 3. I'm specifically looking at column 1. So I'm going to go to column 1 and eliminate that. So then all I have left is -7, 5, 8, -3. Those are the remaining numbers I have. Keep them in their specific spots. Now what you're going to do with these remaining 4 numbers is find the determinant. So, downwards diagonal, -7 times -3 is 21. Then do the upwards diagonal, and that'll give you 40. Once you have those 2 numbers, subtract. 21 minus 40 should give you -19. And that is your minor. That's how you do it. Just going to double check this real quick to make sure I did it right. Row 2, column 1, downwards, upwards. Good. So that's the minor of that one. Oh. Now let's do the minor of this one. This one is row 1, column 3. So let's look at the rows. I specifically am looking at row 1. So let's eliminate row 1. Now look at the columns. I am looking at column 3. So I'm going to eliminate column 3. So all that leaves me with is 5, 8, 3, 8. Keep those in their spots. 5, 8, 3, 8. Now, find your determinant. Downwards diagonal, 5 times 8 is 40. Upwards diagonal, give me a second, I had a brain fart. 5 times 8 is 40. 3 times 8 is 24. And once you have those 2 numbers, subtract. And that should give you 16 as that minor. And there you go. That's how you find a minor. Next vocabulary is cofactors. Cofactors are very similar to minors. They just depend on your sign. If I read the sentence, the cofactor is a special type of minor. If A plus J is odd, the cofactor is the negative of the minor. If I plus J is even, or if you add the row and the columns together and it's even, then your cofactor will be the same as your minor. So how about this? Let's go ahead and for right now, let's find the minor of this. So in other words, row 2, column 1. Start with your row, eliminate row 2. Then go to your columns, eliminate column 1. So then you're left with -9, 4, 7, -8. Go ahead, find the determinant of that. -9, 4, 7, -8. Downwards diagonal is 72. Upwards diagonal, 7 times 4 is 28. And once you have those 2 numbers, subtract. So then 72 minus 28 is 44. Now that's the minor. Now to find the cofactor, I need you to take these 2 numbers, add them together. 2 plus 1 is 3. Now, this is odd. So since it's odd, the cofactor will be the negative of the minor. So your cofactor is going to be the negative of our minor, which is 44, or negative. And that will be the cofactor, -44. Okay, so that's how you do the first one. I'm going to go ahead and erase this now so I can make room for the bottom one. Okay, now let's look at the bottom one. For the time being, let's go ahead and just find the minor. So row 1, column 3. Look at the rows. We're going to eliminate column 1. Now look at the columns. We're going to eliminate column 3. So now take your remaining numbers, 7, 6, 1, 7. Find the determinant. The downwards diagonal will give you 49. The upwards diagonal will give you 6. 49, yes. 6, yes. Then subtract the 2. 49 minus 6 will give you 43. Now that's your minor. Now step 2. Take these two numbers, add them together. 1 plus 3, which is 4. This is even. And if you read the instructions, if the addition of those is even, then the cofactor is the minor. So in other words, our minor and our cofactor will be the same. So 43 is the answer for that one. And that is how you find a cofactor. And with that said, to move on to the final part of this video. Solving systems the Cramer way. Or in other words, I have a system here and I need to find the x, y, and z values that will make each one of these true. The first thing I want you to do is put in the missing variables. So like, for example, this equation is missing a z. So let's squeeze a z into that equation. X, or 1x, plus 8y, but I'm going to put in a 0 for the z, and that's going to equal 65. Now the second equation is missing an x, so I'm going to squeeze in 0x, then plus 1y plus 14z equals 22. The last one is missing a y, so 18x plus 0y plus 4z equals 22. There you go. That's step 1. The second step, I want you to find the determinant of the variables. Or in other words, take these numbers, then take these numbers, and we are going to make a 3x3 matrix and find the determinant. So let's do that. My first column will be 1, 0, 18. My second row or column will be 8, 1, 0. And my last column will be 0, 14, and then 4. And then we're going to find the determinant. First, copy these two columns off to the side. Then, the downwards diagonals are first. Multiply those together, and you get 4. Then we got to do 8 times 14 times 18. And that should give you 16. And then the last diagonal will give you 0. Now the upwards diagonals. The first one multiplies to 0. The second one multiplies to 0. The last one multiplies to 0. Add all the blues together, and you'll get 20/20. Add all the reds together, you get 0. So 20/20 and 0, subtract, and your determinant is 20/20. Now, keep note of this. Keep note of this 20/20. We're going to need it for the second half of this example. Now, I am going to show you how to find the x of this solution. To find the x, make a fraction. On the bottom of your fraction, you're going to put 20/20, the determinant that you found on the previous slide. On the top, you are going to make determinant bars. And in this determinant bars, we're going to be putting 3 ovals. But for the time being, temporarily, label your ovals as X, Y, and Z. Don't put anything underneath X, Y, and Z just yet. Now, when I say X, Y, and Z, I'm talking about this X oval, this Y oval, and this Z oval. But there's actually a 4th oval that comes into play. It's called the Cramer oval. It's called Cramer for a reason. You'll see why in a second. Now, heads up. We're solving for x, which means I shouldn't have this x oval here. I already have an x here, so I don't need this one. So I'm going to have to put a different oval in its place. And the oval that's going to go in its place is the Cramer oval. So underneath the C, or the Cramer, I'm going to put the oval 65, 22, 22. Underneath the Y, I'm going to put the green 8, the green 1, and the green 0. Underneath the Z, I'm going to put the blue 0, the blue 14, and the blue 4. And that's the formula you will use. And then you'd have to find the determinant of the top and then divide by 20/20. And that is how you would find your x. Now let's do all of that work on the next slide. If you need to, pause the video so you can write all of this down real quick. Then resume the video so you can follow my work. Go ahead, pause the video for right now. Okay, you should have resumed by now. You should have all this written down. Now let's do the work. So, to solve the determinant on the top, take your first 2 columns, copy them off to the side. And now, just as always, let's do the downwards diagonals first. 65 times 1 times 4, which should get you off to the side. I'll put it right here. 260. Now the next oval. 8 times 14 times 22. Which should get you 2464. And then your final oval will get you 0. Now the upwards diagonals. The first one gets you 0. The second one is also 0. The last one is 4 times 22 times 8. 4 times 22 times 8 should get you 704. Add all the blues together. You should get 2724. Add all the reds, and you should get 704. Once you have those two numbers, subtract. And you should get 2020. Now remember, that was just the top. We still need to divide by the bottom. And the bottom is 2020. So x equals 2020 divided by 2020, which gives you that x is 1. Now, that's only the first part of our answer. We still need, well, we just found the x. We still need a y, and we need a z. You could do the same Cramer's rule for y and z, but you could just plug and chug. For example, you know that x is 1. Why don't you plug that into the first equation? Let's do that off to the side. So for x, I'm going to plug in 1 and plus 8y plus 0z. And that's going to equal 65. 0z, you don't need that. So 1 plus 8y equals 65. Subtract the 1 to both sides, and you'll get 8y equals 64. Divide by 8, and you get that y is 8. So there you go. That's your y. And then to find your z, why don't you take this y equals 8, plug it into the second equation. So 0x plus, well, y, but y is now 8, plus 14z equals 22. Don't need that anymore. 8 plus 14z is equal to 22. Subtract 8 to both sides, and you get 14z equals 22 minus 8, which is 14. Divide by 14. Z is 1. And there you go. Your final answer would be the ordered pair 181. And it also says that on the bottom to double check. And there you go. That's how you find x, y, and z using Cramer's rule. And with that, this slide and this entire video is complete. Now I'm going to go drink some hot tea.